Here's an opportunity to practice determining a linear model with the context of blood alcohol content. We're given the information that a man drinks 4 beers, and after 1 hour, his blood alcohol content is 0.16, and then after 3 hours, his blood alcohol content is 0.13. We're going to use this information to determine a linear model to represent his blood alcohol content T hours after consuming the 4 beers. So the first thing that we need to recognize is the fact that he had 4 beers is irrelevant to our goal of determining a linear model. We're going to use the information of how he's processing the alcohol. So we have a set of ordered pairs in the form T, comma, B for time after consuming the alcohol, and B standing for our blood alcohol content. So the first set of ordered pairs is 1, comma, 0.16, and then the second ordered pair is 3, comma, 0.13. Now, we might remember our slope formula as change in y over change in x, but we do not have a y or an x here. So we need to recognize that the slope formula that we will be using, our y value is represented by the second coordinate, or B, our blood alcohol content, and our first coordinate is T. So that might help us transition there. And remember, the delta symbol, the change symbol, indicates we're going to find the difference and we're going to subtract. So our slope, or rate of change, is 0.13 minus 0.16 over the change in time. And we need to make sure that we are putting the information together as it was presented. So for example, please notice that the blood alcohol content of 0.13 is above the time of 3 hours. Also notice that the numerator gives us a negative value. So 0.13 minus 0.16 gives us negative 0.03, and then divided by 2 gives us a rate of change of negative 0.015. What we do not know is what was this man's starting blood alcohol content after he drank the 4 beers. So we can use one of the ordered pairs, and I'm going to just choose the first one. It's just a choice. And we can use our point slope formula. So B minus B1 is equal to our slope times T minus T1, which gives us B minus 0.16 equals negative 0.015 times T minus 1. Distributing, and watch your operations. And then solving for B by adding. So we have positive 0.015 plus 0.16, which gives us a positive 0.175. And the last thing that we want to recognize is this is our slope, or rate of change. And this gives us our starting blood alcohol content or our vertical intercept.